Hello mathematicians, we're now going to have a look at equations of lines. I think I can confidently say that this first bit you will have seen in junior school, and that's that the equation of a line with gradient m and y-intercept b. Interesting to notice that that's actually c in everywhere but Australia, and it's c in the new general syllabus as well, just to be consistent. But we'll stick with what's in the text, y equals mx plus b. So b, of course, is the y-intercept, which is the point where we cross the vertical axis, which we find by putting x equals 0 if we have to, but we just do it by observation. And m is the gradient, which you now know all about. So if we have a very quick look at the gradient-intercept form on GeoGebra, so here we have, as you will have known since year 8 probably, as we change the y-intercept, so we vary that. When the y-intercept is 0 or close enough, the line passes through the origin. And down here, -2, blah, blah. Change the gradient, so this is a negative gradient. When we come down to a 0 gradient, we've got the horizontal line, and we go to a positive gradient. I don't know whether I can just make it animate on here. No, I can't. Okay, so that's just refreshing hopefully what you've known for a long time. And hopefully also what you're now starting to be more familiar with is that we could rewrite the equation of the line in standard form as this. So it's all the variables gathered to one side. A is going to be a positive number, and this is the way the textbook will often have their equations of the straight line written. If we rearrange this equation to make y the subject, so it looked like this one up here, then we can see that the gradient would be minus a over b, and the y-intercept would be minus c over a. Because I'm too lazy to memorize those, then that's usually what I do, change the subject back to y. But if you're, and you should be, good, quick, gradient minus a over b, and y-intercept c minus c over a. Of course, that should be b. I'll change that in the notes that go up on the page. Okay, so if we are going to use those facts up above, then we need our equations written in the forms up above, either standard form or gradient-intercept form. And we want to write down the gradient. Well, actually, this one says solve each equation for y. They want you to make y the subject. So if we did that, if we switch the y over, y equals x plus 3. So gradient 1, y-intercept of 3. But just checking, because it's written in standard form at the moment, gradient is minus b over a, so that's minus 1 over 1, as we saw. And it's minus c over b, so that's minus 3 over minus 1, which is plus 3. This one here, not sure even why I've included this, so y equals 2x plus 5, gradient 2, y-intercept 5. This one here is probably one where it's quicker to rewrite it in standard form. So gradient is minus 4 over 3, and y-intercept is 5 over 4, but they've said to change the subject to y, so that gives us 4y equals 5 minus 3x, so y is 5 on 4 minus 3 on 4x, to give us the answers as we set up above. Now, next part, find the gradient of the three lines here, and hence show that they enclose a right angle triangle. So we could have a go at quickly sketching these. It might speed things up, but the time that it takes to sketch them, we might as well just find the gradient. They're all written in standard form, so if we take them one at a time and find the gradient, so for this one here, the gradient will be 5 over 7 minus a over b, so 5 over 7. The gradient of this one will be 5 over 2, and the gradient of this one will be minus 7 over 5. Now the two that we're going to show as being the sides of a right angle triangle, it will be clearly this one and this one, because the product of their gradients, so the gradient of, now these are all unlabeled, so we'll just call this line 1, so the gradient of line 1, 2, 3, so the gradient of line 1 times the gradient of line 3 is 5 on 7, so this seems like overkill, but trust me, examiners love it, which equals minus 1, therefore they're perpendicular, therefore form the sides of a right angle triangle, angled triangle, and the other one, because it's at an angle to both of them, must intercept both 1 and 3 at some point, and therefore enclose the right angle triangle. So have a go at 5C.